Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about inferential statistics. Now the question that I've chosen to go through here is 2019 Paper 2 Question 8 Part B. In this question we're told that a group of transition year students are doing a survey about daylight savings time. They take a random sample of 800 people and they conduct their survey. Based on the fact that they've surveyed 800 people, we're asked to find the margin of error and give our answer as a percentage to 2 decimal places. Now, so if our sample size is 800, that's n. N is the letter we use to signify the size of our sample. And you need to know or memorize the formula for the margin of error is 1 over the square root of n, where n is the number of people in your sample. So in this case, the margin of error was 1 over the square root of 800. You just plug all of that into your calculator and it works out as 0.035355. Now I was asked to get this as a percentage, so I have to multiply it by 100. If you multiply that by 100, you get 3.54%. Rounded off to 2 decimal places, my final answer is 3.54%. Okay, in the second part of this question, we're told that of the 800 people that the TY students surveyed, 350 of them agreed with the EU's report or the EU's referendum to abolish daylight savings time. So the 350 and the 800 allow me to calculate P hat. P hat, or P with these lines above it, represents the proportion of the sample who agreed. In this case, the proportion of the sample who agreed with abolishing daylight saving hours, and it works out as 0.4375, or in other words, 43.75%. But the TY students surveyed 800 people in their local area, but maybe there's 10,000 people in their local area. The 800 people they surveyed might have been biased. So just because 43.75% of the people they surveyed want to abolish daylight savings hours, that doesn't mean that if they surveyed the entire population that 43% would want to abolish it. It's probably close enough to 43%, but it's not quite the exact same as the 800 people. So hence we have to come up with a confidence interval. In order to come up with a confidence interval, this formula in the box, you have to memorize this. To come up with a 95% confidence interval, you need to use this. Ultimately, we're trying to find P. P represents the proportion of the entire population who agree with abolishing daylight savings hours. And in order to calculate a 95% interval for the proportion of the population who agree with abolishing it, it's P hat, the result of your sample, plus the margin of error. That's the higher range. The lower range is P hat minus the margin of error. Now we know what P hat is, and we've already calculated the margin of error as 0.0354. So it's important you understand what the 0.0354 represents. That's the 3.54% that we had in B part 1. The margin of error is the margin by which this figure could deviate from the actual population average. If 43% of our sample agree with abolishing the rule, the fact that I've only surveyed 800 people means that this isn't exactly accurate. The fact that I've surveyed 800 people means that at the very most, this figure is off by 3.54%. So that's why I added on and I also subtracted. When you add it on, you get 0.4721. When you subtract it, you get 0.4021. Sorry, that should be 0.4729. When you add it on, you get 0.4729. So the proportion of people, if we actually surveyed everyone in this population, the proportion who would have agreed with it is actually somewhere between 0.4021 and 0.4729. Now you can leave your answer as a percentage here. It's 47.29% and 40.21%. It's important you understand what this is. This is a 95% confidence interval. Based on the amount of people that were surveyed and the results of the survey, I can be 95% confident that if we surveyed every single person in this population, between 40.21% and 47.29% of that population would agree with abolishing daylight savings hours. In the final part of this question, we're told that a local newspaper claims that 50% of the local population agree with EU proposal to abolish daylight savings time. And we're asked to conduct a hypothesis test at a 5% level of significance to investigate this claim. We need to state our null hypothesis, our alternative hypothesis, make a conclusion, and give a reason for that conclusion. So we have to do a hypothesis test based on the local newspaper's claim. The local newspaper claimed that 50% of the population agree with the proposal. So our null hypothesis is exactly that. 50% of the population support the proposal. Your null hypothesis, you would always agree with the claim. You will assume that what the newspaper said is true. The alternative hypothesis is then the opposite of that. In this case, the level of support is not 50%. Now, in order to conduct this hypothesis test, we need to look at the confidence interval from B part 1. In B part 1, we concluded that between 40.21 and 47.29% of the population agree with the proposal. So clearly the 50% that the newspaper is claiming does not lie within this range. Because it doesn't lie within this range, my conclusion is that I'm going to reject the null hypothesis. If we reject the null hypothesis, we reiterate the alternative hypothesis. So we say that we're going to reject the null hypothesis. The level of support is not 50%. And the reason we're rejecting the null hypothesis is that 50% does not lie within the confidence interval. Clearly 50% does not lie within this confidence interval. Now I hope this video makes sense. If there's anything you're unsure of there, or you'd like me to clarify something, just let me know in class or send me an email and I'll explain it differently.